If you have studied previous modules, you are already aware about concept of digital libraries. However, just to recall, digital libraries are nothing but services related to management and organization of available digital information and its retrieval with proper user interfacing. It also includes archiving and preservation of digital material, social issues attached to the same, along with its application and evolution to specific focused areas. To achieve all, there are certain expectations from the software or solution which helps to create digital libraries.
For a proper digital library solution, primarily it is being expected that it should be cost-effective in terms of hardware and software platform to be procured and management thereafter. The digital library software is also expected to be technically simple, easy to install and manage, so that a layman with working knowledge of information technology can install and administer the same. The solution should be robust and scalable in such a way that it can handle large volume of data seamlessly along with interoperational modular open architecture so that the necessary customization can be done easily without being dependent on software specialists. Digital library software should have user-friendly multi-user interface so that multiple entities can use and administer the software simultaneously. It is also desirable that it should be platform independent so it can run on any popular software and hardware platform. Last but not the least, it must have capability to handle all types of digital object. The object can be dataset, document, multimedia, or say any digital format.
There is one-stop solution which meets all the expectations described previously. That is dspace. It is a platform that captures items in any format and it distributes it over the web. It indexes digital items so user can easily search and retrieve them. dspace can also preserve the digital content over the long term. dspace is typically being used to create digital library with three major roles. First, it facilitates capture and ingestion of material with associated metadata. Second, dspace provides easy access to the material with user-friendly searching and listing mechanism. Third, it facilitates long-term preservation of digital material. When initiated, dspace was joint project of Massachusetts Institute of Technology and Hewlett-Packard. dspace project is now being handed over by DuraSpace, a non-for-profit organization.
Historically speaking, dspace project was started in the year 2000 as part of MIT and HP Alliance. The first version was released in the year 2002.
dspace has become quite popular among digital library implementers because it is open source and freely available software, and it is being backed by very large worldwide user community who are ready to help. dspace software has been packaged in a way that it is very easy to use. It handles content in number of digital format, and the major advantage is content in dspace can be made searchable through search engines like Google Scholar. Thus one can increase outreach of digital library without much effort.
dspace can be used to store any type of digital material. It can store journal papers, datasets, electronic theses, reports, conference posters, videos, images. Logically speaking, dspace can be used to store any material which is available in digital format.
dspace is basically an open source software available under Berkeley software distribution. BSD license wherein one can use and redistribute source as well as binaries or executable program, dspace software can be obtained from www.dspace.org or SourceForge's dspace project site. Dspace is having community-based development model wherein there is subversion, in short SVN, based common source code control repository which is having dedicated committers and contributors. This developer community welcomes everyone to submit bug reports, patches, feature requests and other related things. There are number of active discussion groups and email lists are available for the dspace support.
An information model in software engineering is a representation of concepts and the relationships, constraints, rules, and operations to specify data, semantics for a chosen domain of discourse. We will be discussing information model of dspace.
Information model of dspace is broadly divided in 4 components, that is, communities, collections, items, and bit streams. Community reflects the unit of an organization. Collection in each community is distinct grouping of items. Items are logical contained objects, whereas bit stream are individual files.
The way data is organized in dspace is supposed to reflect the structure of the organization and its digital collection. Each dspace site is divided into communities, which can be further divided into sub-communities, reflecting the typical university structure of college, department, research center or laboratory. Communities contains collections, which are groupings of related content. A collection may appear in more than one community. Each collection is composed of items, which are the basic archival elements of the archive. Each item is owned by one collection. Additionally, an item may appear in additional collections. However, every item has one and only one owning collection. Items are further subdivided into named bundles of bit streams. Bit streams are, as the name suggests, streams of bits, usually ordinary computer files. Bit streams that are somehow closely related, for example, HTML files and images that compose a single HTML document, are organized into bundles.
As discussed earlier, communities and collections are used to organize digital content or items into a hierarchical form. It also contains limited set of descriptive metadata like name, description, license and availability for the particular community and collection, etc. As shown in the example, Digital Library Implementer can create communities based on logical grouping of digital items and then further subdivide into the collections.
Items are logical units of content which consist doubling core based metadata as well as other metadata which has been encoded as bitstream. The item can be an electronic thesis, an ebook, photographs, a complete web page which can include images and style sheets associated with HTML page. Each item can contain one or multiple files along with metadata.
In short, term is composed of doubling core metadata and bundles of bit streams as shown in the example.
dspace facilitates all three types of metadata, that is, descriptive, administrative and structural. Descriptive metadata can be anything which describes the item. It takes care of all elements of doubling core metadata set. dspace also supports non-doubling core metadata. These elements may not be searchable. However, one can customize dspace with some programming efforts to search non-doubling core metadata elements. administrative metadata associated with an item can be access restrictions, means who can access, remove or modify an item. There is no standard format available for this type of metadata. Structural metadata describes very basic attributes about item. For example, what are the bit stream that contain in an item, or under which community and collection that item belongs to.
Bitstreams are individual digital files which are having limited sets of descriptive metadata like name, size of the file, format of the file, etc. A PDF file, Word document, JPEG or BMP picture, executable program, etc. can be considered as bitstream.
Bundles are basically nothing but group of related files. For example, when you have a HTML page, it may also contain link to other HTML documents, images, Flash object, etc. Therefore, to view that HTML page, you also need to have all associated file. Therefore, HTML file along with other associated files makes a bundle. Dspace doesn't support any metadata for bundles.
Now we have gone through information model of dspace. In this subsection, we will focus on components and features of dspace.
The architecture of dspace has been divided into three major parts. That is, dspace public API on the top, business logic layer in the middle, and storage API at the bottom. dspace public API takes care of user interfacing and services. It contains components for web user interfacing, federation services, metadata providing services as defined by Open Archive Initiatives Protocol, interfaces for web services like SWORD, which is Simple Web Service offering repository deposit, etc. This public API components interacts with business logic layer in the middle, which provides search and browse components, handle manager, history manager, which takes care of logs and statistics. Business logic layer also contains components to manage ingestion process and workflow, components to manage e-persons, groups and their authorization, along with content management API and administrative toolkit. The bottom layer, the storage API, having two major components. One is Relational Database Management System wrapper, which connects to RDBMS like Postgres or Oracle through Java database connectivity, and the Bitstream Storage Manager, which directly interact with file system to store bitstreams.
dspace provides facility to create new metadata registry or manage existing Dublin core metadata registry, wherein digital library implementer can manage and customize metadata elements. Metadata registry has three major components, that is schema, element and qualifier.
In addition to metadata registry, dspace also features registry to handle file formats. These file formats can be managed based on three levels, that is supported, known and unknown. Here, dspace administrator can specify MIME type, name, long description and support level of the file along with file extension.
Persons or users who interact with dspace are called e-people. It is basically dspace user accounts. dspace provides facility to permit these e-people to log in to the site, sign up to receive notification changes to subscription, submit new items to the collections, administer collection, communities or entire dspace site. These e-people can also be managed by forming groups.
Authorization system in dspace enables administrator to give e-people the ability to perform add and remove operation by which an e-person can remove or add any community, collection or item. As a collection administrator, e-person can edit an item's metadata, withdraw items or can map the items into the collection. Write permission enables e-person to add or remove bit streams, whereas read permission enables only reading of bit streams.
Ingestion process is nothing but getting or putting contents into dspace. Dspace facilitates batch import as well as web-based submission. In batch import, multiple items can be submitted to dspace in one shot. This requires item to be in specific format along with metadata encoded in XML. Whereas in web-based submission, only one item can go each time the item being submitted has to go through a workflow process defined for that collection.
A collection's workflow can have up to 3 steps. Each collection may have an associated e-person group for performing each step. If no group is associated with a certain step, that step is kept. If a collection has no e-person group associated with any step, submissions to that collection are ingested straight into the main archive. In other words, the sequence is this. The collection receives a submission. If the collection has a group assigned for workflow step 1, that step is invoked and the group is notified. Otherwise, workflow step 1 is skipped. Likewise, workflow step 2 and 3 are performed if and only if the collection has a group assigned to those steps. When a step is invoked, the submission is put into the task pool of the steps associated group. One member of that group takes the task from the pool and it is then removed from the task pool to avoid the situation where several people in the group may be performing the same task without realizing it.
dspace allows end users to discover content in a number of ways, including via external reference such as handle, searching for one or more keywords in metadata or extracted full text, browsing through title, author, date or subject indices with optional image thumbnails, etc.
In present web world, universal resource location URL of a digital content may change due to the change in hardware or software, change in network or because of political change. This can be handled by creating a permanent URL independent of the repository. Handle system in dspace provides a persistent handle for each item if configured properly.
The Open Archives initiative has developed a protocol for metadata harvesting. This allows sites to programmatically retrieve or harvest the metadata from several sources and offer services using that metadata, such as indexing or linking services. Such a service could allow users to access information from a large number of sites from one place. dspace exposes the Dublin core metadata for items that are publicly accessible. Additionally, the collection structure is also exposed via the OAI protocol's sets mechanism.
dspace offers system statistics for administrator users as well as user statistics on the level of items, communities and collections. dspace also provides customizable general overview of activities in the archive, by default including number of items archived, number of bitstream views, number of item page views, number of collection page views, number of community page views, number of user logins, number of searches performed, number of license rejections, number of OAI requests.
SWORD, Simple Web Service Offering Repository Deposit, is a protocol that allows the remote deposit of items into repositories. SWORD was further developed in SWORD version 2 to add the ability to retrieve, update, or delete deposits. dspace supports the SWORD protocol via the SWORD web application and SWORD v2 via the SWORD v2 web application. dspace supports the Open URL protocol from SFX in a rather simple fashion. If your institution has an SFX server, dspace will display an Open URL link on every item page automatically using the Dublin Core metadata. Additionally, dspace can respond to incoming Open URLs too.
dspace provides various flexibility and customization options. The areas that can be customized are submission process, in which one can configure the submission steps to suit organization. One can also customize browse and search terms, in which fields and files can be chosen to index and display in the browse interface. dspace also provides flexibility to choose database. One can choose Postgres or Oracle. dspace can be customized to work with other web services. Using light network interface, you can pull or push content to or from dspace. You can create your own user interface or interacting with dspace.
The Shodh Ganga at Inflipnet Center provides a platform for research students to deposit their PhD thesis and make it available to the entire scholarly community in open access. The repository has the ability to capture, index, store, disseminate, and preserve ETDs submitted by the researchers. This site has been created using dspace platform with great level of customization at interfacing and submission level. This site is using JSP User Interface.
This repository contains the research publication of the faculty and student of the Raman Research Institute, the collected papers of Dr. C.V. Raman, and the historical records of the institute, that is, annual reports and newspaper clippings, are also housed here.